All right, so we have target 7 here, and target 7 reads, for a complex number a plus z equals a plus bi defined by real numbers a and b, the conjugate of z is defined as z bar equals a minus bi. So essentially what we're doing is we're just flipping the sign on the imaginary part, and that's called a conjugate. So now we have let z be a complex number such that the magnitude of z, so the magnitude of z is root a squared plus b squared. Think of it like, you can think of it on the unit circle or Pythagorean theorem, anything like that. And we know that z over 2 minus z plus z bar over 2 minus z bar is equal to 1. And we want to compute the real component of z, which is a. So express your answer as a common fraction. So it would correspond to a for a complex number. So the first thing we notice here is that we have these fractions, and I don't want to deal with that. So I'm going to multiply the entire thing by 2 minus z times 2 minus z bar to just get rid of those fractions. So that gives us z times 2 minus z bar plus z bar times 2 minus z is equal to, on the right side, it's just 2 minus z times 2 minus z bar. So we're going to just multiply that out. So that gives us 4 minus 2z minus 2z bar plus z times z bar. Now, on the left-hand side, if we expand this, right, that gives us 2z plus 2z bar minus 2z bar is equal to 4 minus, on the right-hand side, we can't really simplify anything. Now we have this equation, right? And it might seem that we can't actually do that much with this, but we kind of can. If we rearrange the equation as follows, by moving the z and the z bar terms to the left-hand side to get 4z plus 4z bar, and moving everything else to the right-hand side, right, that gives us 4z plus 4z bar equals 4 plus 3 times z bar. Now, there's a couple properties of complex numbers that come into play here. Number one is that if I add together, say, z plus z bar, right, and using the a plus bi definition, that equals a plus bi plus a minus bi, right? And that equals 2a, which is equal to 2 times the real component of z. Now, the second thing that we need to note is that if I multiply z and z bar, then z bar is equal to a squared plus b squared, which is equal to the magnitude of z squared. Now we know from this, right, that the magnitude of z is 1. So that means that the magnitude of z squared, z bar, is equal to also 1. So that means that if we come down here, right, and we rewrite this this equation, so we have 4 times z plus z bar is equal to 4 plus 3 times the magnitude of z squared. This is 4 times 2 times the real component of z is equal to 4 plus 3. So that means that the real component of z is equal to 7/8, and that is our answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.